So let's understand analog matrix computing. Why is this important? So for deep learning, or the science that is behind the AI, which is deep learning computing, majority of the computing required for or majority of mathematics required underneath is what is called matrix convolution. People also call it tensor computing. We call it matrix convolution. These are all same. These all mean the same thing. And it is known that for the analog form of computing is better, far better, if you were to use concepts of analog electronics engineering. So, and it's amazing that only for matrix computing, analog way of computing is better. For everything else, analog costs more power and is more expensive.
Hey, it's Eamon with ipXchange. We're in the ipXchange studios for another pre-embedded world ipXperience, this time with GP Singh from Ambient Scientific. So you may remember a chat between Guy and GP at CES, all about AI at ultra low power. So what I thought would be cool, because Ambient Scientific are going to be joining ipXchange as one of our official partners on our booth for a 101, was to do a little bit of background on the chip itself and then go into the applications that you can use it with. So really, really good to meet you, GP, and thank you for coming aboard. So I guess first question would be Ambient Scientific. It's kind of in the name that your chips are so low power they can be powered using harvested energy. But what's the magic behind these chips, and how do they do AI so well?
Yeah, thank you very much, Eamon, first of all, for having me here.
No worries.
As you said, and this been after a very long time where I did not have to explain about the chip, and as you said, it is in the name, Ambient Scientific. The name itself was picked so that we were targeted to do the computing for our common day usage, for our environmental friendly world. And so for common people, extremely low power, because power consumption can cause a lot of trouble. So computing that can be spread around in our ambience is what ambient computing is all about. But in addition to the computing in general, we are specific to making to speeding up the computing, or making computing particular to what is called artificial intelligence, but in more technical language, it is called deep learning computing.
Okay,
Okay.
nice.
So artificial intelligence is a name that is commonly used. The underlying engineering or the technical people use more deep learning or machine learning as a as the main terms to describe it. Uh, we started our journey quite a while ago, actually, and it has taken us quite a bit of time to break the code, so to say. As human being, we discover, we don't invent. We have discovered.
Yes, yeah, that's a nice way to put it.
Yes. So we have, as a team, Ambient Scientific team has discovered how deep learning computing or AI computing can be done very economically. What that means is economically in power consumption, so much so that this very demanding form of computing called deep learning can be done on small batteries, coin cell batteries, or even tiny batteries. And then some of the applications can even be run on energy harvesting. That can be, you can harvest energy from different sources. So economic enough in power consumption that you can have a device, chargeless device, perpetually running, doing intelligent things. Economic enough to be affordable by people. So,
Okay. Yeah, that's also very important.
correct. So, we
Yeah.
intend to change the landscape wherein intelligent devices, Apple will be a good example, can cost hundreds of dollars, sometimes thousands of dollars. Bring that cost to tens or below 20 bucks, below 10 bucks, $10. So
Nice.
becomes affordable for people. Okay. Economic enough that the performance will not be degraded. Now, this means in this case is that it will still have enough or large enough performance that while it is cheap enough, while it can run on a small battery, the performance is still high. So in the language of performance, higher performance is economic for people because then it becomes affordable. So we have been able to crack the code of the technology that can achieve such a these features.
Cool. And I'm guessing that the key thing that sets Ambient Scientific apart is the analog matrix technology, which I mean, I've seen analog matrix computing from some competitors, but never at this level of low power. So, how does, if that is the secret, how does analog matrix computing help with deep learning?
So first of all, I do want to clarify. Ambient scientific team had to change the concept so much so that
Okay.
we had to give it a new name, and we call it
Okay.
DIGAN. It's a short for digital analog.
Okay.
So let's understand analog matrix computing. Why is this important? So for deep learning or the science that is behind the AI, which is deep learning computing, majority of the computing required for or majority of mathematics required underneath is what is called matrix convolution. People also call it tensor computing. Uh,
Okay.
we call it matrix convolution. These are all same. These all mean the same thing. And it is known that for the analog form of computing is better, far better, if you were to use concepts of analog electronics engineering.
Okay.
So, and it's amazing that only for matrix computing, analog way of computing is better. For everything else, analog costs more power and is more expensive.
Oh,
This is a very unique.
that's very strange.
Yes.
What is it about matrix convolution that really benefits from analog?
Simply because there is actually the electronic components have hidden features in them, and analog, this is called resistances, um, conductance factors. Digital engineering or digital electronics ignores these factors and just computes zeros and ones. But the analog computing actually takes into account these characteristics of these components. So, for example, if you were to pass a current through a resistance, it automatically gets multiplied. Now, even in digital engineering, we pass current through a component all the time, but whatever happens in passing that current through a component, we completely ignore it. It's actually an
Okay.
overhead in digital engineering. But in analog engineering, we use this particular phenomenon to do a multiplication, which is in digital engineering is an ignored property. So matrix computing is mostly multiply and add function. So analog this hidden property of analog of any electronic component actually, where when you pass current through it, there's a multiplication that happens automatically. While in
Okay.
digital engineering we ignore it, in analog engineering we basically harvest this particular property and use it to make the computing. So what it means is you're actually computing for free. You're doing matrix computing almost for free if you use analog concepts. This is a known thing. This is actually ambient team did not discover this phenomenon. This has been known for very long time. Actually, analog computing came before digital computing. So
Yeah, I think I remember you saying in Guy's interview that people who have worked for 50 years in the field will probably be able to design AI better than newer people because they know the fundamentals of analog computing, and you can really utilize that for saving yourself power.
yes, so this hidden
Yeah.
feature is what really gets exploited. Okay, so analog the concept is known very well. The problem is that making it work is actually very difficult.
Yes.
So so it's very sensitive, and one needs to really find new ways to eliminate the sensitivity. It is sensitive to temperature, it is sensitive to the manufacturing variations. So we had to change the concept so much so that we had to give this a new name. So our
Oh, fair enough.
technology
Okay.
actually is not a classical analog matrix computing. It changes it dramatically to make it what we call digital analog. So we mix the two in such a way that we are able to eliminate the sensitivity, and we introduce quite a bit of digital in it. By doing so, we are able to preserve the power consumption, performance, and the cost benefits without giving up. uh, I mean, we are able to still do enough, gain enough advantage into these three features, and not become as bad as digital. So this is the we are walking the middle path. I don't know.
Okay.
Did that make sense?
No, no, that was very cool. So, how does that part of ambient scientific solution translate to the neural networks that you'd use to create your typical AI application?
So the way we are doing this so-called matrix computing using this DGAN, digital and or DGAN technology, is no different than the digital or the classical way of computing. So from user point of view, this is completely invisible. The user never
Okay.
sees what is actually doing the computing inside. So inside is remains pretty much same. It's like, if you were taking a DC motor, or if you're taking a heater, whether it's an oil that is being heated inside or is the hot air blowing, doesn't matter. For the user, you still
Yeah.
feel warm, right?
Okay. Yeah.
So same way here,
Okay.
the user never sees and the programmers never see the difference. So from outside, it looks exactly like a digital computing. So there's no difference.
But it just saves lots and lots of power.
That's correct. It
Okay.
conserve power and able to give the performance, and it can be done in a very small areas, very compact, so it becomes very affordable.
Oh, okay, cool. So I'm I wrote up a piece on the GPX5 and the GPX10.
Mhm.
So they also have, I believe, a Cortex M processor as well in them.
Yes.
So where does that sit in terms of when someone's building an application with Ambient Scientific? I'm guessing that's the part that they'll feel like they're programming. But yeah, how does that fit in?
Yeah, okay. So looks like this is very technical, very technical. So let's get into
Oh, sorry.
technique. So when one is doing what is called this deep learning based applications,
Okay.
these applications now have two planes. One will be called data plane, another will be called control plane. Now, these
Okay.
data plane and control plane, they are present in all computing uh, architectures or all computing environment. It's just that when you use deep learning type of computing, the data planes becomes very big, so massive that you need to do something special to make it happen. This is where this gigant technology comes.
Okay.
But the control plane still remains. So we being a startup, we only invent what is necessary to, or we only discover what is necessary to discover. Whatever already existed in the market, or whatever has already been discovered, or whatever has been developed already, we do not want to reinvent the wheel. So for the control
Yeah.
plane, we still used what is existing in the market, and the candidates are ARM processor is a very is one of the main candidate. RISC-V nowadays have started coming up. There are also a couple of other smaller processors that exist in the market, but we picked ARM because of its developed ecosystem. So ARM does what you will call control plane computing. Our special processor that we have developed, which we call MXX processor, and the first version is called MX8 processor. So MX8 is for computing the data plane, and for ARM is
Okay.
controlling the computing the control plane.
Oh, cool. Okay. So in terms of when you get it, oh, were you going to say something?
Yeah, from the user
Oh,
point of view, there are actually two distinct planes. Application will have both the deep learning or the data plane, the main part of the data plane, and then the classical control plane, which is the classical algorithm. So applications need to have both. That's why there is need for both. The
yeah.
company, either you have to discover or invent both of them, or take whatever exists in the market for whatever part you can.
Cool. And so, is the for the deep learning plane, are you still using kind of typical market AI environments such as kind of TensorFlow or Edge Impulse, those kind of things? So people are still familiar with those when if they decided to use Ambient Scientific chips.
That's exactly what we have to do.
Okay.
And as a company, as we, let me repeat that part, we invent, and also we want our user, uh, they should they should be forced to learn as little as possible, so they should be using their existing methods. So our attempt is our architecture is designed in such a way that the users will not have to learn anything new from how they do their deep learning design. So yes, it is designed to use TensorFlow. You will still write your deep learning algorithms in using Python, and then
Okay.
we construct the tool chain or the software that converts this Python code, or I mean this deep learning algorithms written using TensorFlow, using Python language, into our hardware, our special processor. So from user point of view, we are trying to make it as easy as possible for people to adopt. And if you look at the history of computing, whenever chip companies or chip designers have tried to invent things that are completely new, where the user has to learn a lot of new stuff, generally bad idea.
Yeah, you don't have to have the time to learn the new technology if you need to use it in your job.
Yeah, and it
Yeah.
the users adaptability generally is very poor when the users have to learn new stuff.
Cool. Well, I'm going to say thank you so much for explaining that in detail, because I think I'd be doing our community a disservice if I didn't use this opportunity to find out more about how these devices work, because they're so cutting edge. But I think it's probably time that we focused on some of the applications that you can use
Sure.
Ambient Scientific's chips in. So obviously AI is such a vast field. There's so many things you can do. What are the typical applications and neural networks you see people programming into ambient scientific chips?
Okay. So see the let me answer it in a slightly convoluted way. So allow me.
No, no worries. Matrix
And
convoluted.
yes, see the from how I see it, Eamon, the AI actually arrived too quickly. I mean, injunction or adoption of AI was too quick. From what does that mean? It means that this type of technological changes, they take a lot of time to develop, but we in general have especially in computer world, users have no patience. So whatever is available out there, people start using it almost immediately, and the commercial world, pretty much in their enthusiasm to make more bucks, they just provide the whatever solution is available. So what that means is that so far all of the AI computing has been done in by using the infrastructure, by using the computers, by using the software, by using the hardware that was available as quickly as possible. And so, what does that mean? That means that for AI computing, as you know, today we are using these graphics processing units, right? That were designed for graphics.
Oh, yeah, yeah. Yeah, yeah.
So that's the chip being used. The computer infrastructure. That's why you see we built a large data center. We as a community, compute well, built large data centers to do either retail shops like in Amazon, or we built large data centers to do a search type or advertisement type commercialization like in Google, or we build data center to move our office applications like Word processing or PowerPoint or presentation processing to be also done in the data center. So our personal computers that we worked so hard to make it intelligent became a dumb device again, right? Now, when AI came, AI pretty much uh, landed itself on the same infrastructure. Now, what does that AI mean? So, let's say I want to build an intelligent watch that is able to, or intelligent device, let's say a locket, and I can show you some of these things that we are working on. Uh,
Okay.
that actually needs to do to detect, let's say, asthma attack of, let's say, I have a family member, my mother, for example. If she is having an asthma attack, I want to get notified. If I want to build that device today, the mechanics that people used is that this there will be a sensor, kind of a passive sensor. You can, in common language, call it a dumb sensor that collect the data every second, every moment, and send it to a large data center in Google or Microsoft and Amazon. And these large computers will detect if she is having an asthma attack at any given time or not. So the problem with this type of mechanism is that the communication from this dumb sensor to data center, it costs so much power. Also, it is so costly that most devices or most people cannot really afford it. That's why a small device that is worn as a locket or worn as a watch or as a ring that can detect asthma has not been possible so far. So this is because we as you know, as I said, in it came too quickly. If you took time to develop these intelligent end devices or the on the edge devices, then you wouldn't be forced into this solution which is mostly band-aided. We are changing that paradigm by bringing the intelligence on the extreme edge. And when you bring this intelligence to the extreme edge, then one needs to make it affordable. one needs to make it low power enough so that it can be portable. And that's what we have really done. So now using our chip, one can build intelligence on the extreme edge. And now only when, let's say, this asthma detection as an example, only when somebody actually has an asthma attack, the device will be able to report, and then the information will get transmitted. So not only is our device itself consuming very low power, but also it saves the energy consumption of transmission, which is actually a huge energy consumption.
Yeah.
And also the entire infrastructure cost of transmitting mostly unnecessary data. I mean, even if you have an asthma patient, in a day probability the person will have that attack is very low. That means most of the time I am actually computing, transmitting, sending data to the data center for no action or for no useful information. So this device is able to do that. Now the moment you bring this type of intelligence on the edge, whether a person is having asthma attack or a motor running in my fridge is going to break if the motor is having asthma attack,
Yeah.
or there is a pet who is in some kind of trouble, whether because of a illness or because get hit by a cycle or something, all of these detections become possible. And now you will basically have these intelligent devices. So our first chip, first of all, I'll tell that we actually we have developed a technology in such a way that by multiplying our core, what we'll call AI core, we can build
Okay.
many chips. The first chip alone can do hundreds of such applications. I mean, I can walk you some examples.
Yeah, yeah, please.
This is the box we ship to our customers nowadays, which is for development kit. You know,
Yeah. Okay, cool.
oh, it's upside down. I am Ambient Scientific, and
Yeah, no worries.
we some of the devices I can show you that customers are already working on. Um, Here is that locket I was talking about. This is just a dummy right now, and somebody working to make it real. A customer of ours is working to make it real. Is where uh, not very convenient, but the device goes, our chip goes behind this PCB, and the battery will just
Oh,
be here,
wow.
and I can have it. I mean, any person can wear it just like a locket. It's
Yeah.
a jewelry. You
Nice.
can walk around,
Yeah.
and it's always actually monitoring if somebody has asthma impact. There is a company that is actually working on a similar device, not exactly this shape, but it will be actually doing continuous ECG monitoring or the heart monitoring,
Okay. Yeah, yeah.
and detect some of the anomalies if the some of the heartbeats escape, or which, so that the information can be sent to the doctor. This device is also being designed by our team as a prototype, where it can detect if a person is being attacked, right, by
Okay.
sensing the sound and the motion anomaly. We are able to detect if and this is a big problem in Asian countries, right, Southeast Asia especially, and South Asia especially, where a lot of kids get assaulted, right? So this is able to detect those type of problems. It can also detect if
Okay.
they have a home violence or domestic violence issues, that will also be detectable. And the cost of this device we are targeting below $10. Okay, the final
Oh, wow.
device.
So that's a no-brainer to have.
Correct. So the idea is
Yeah.
that every parent should be able to put it in its kids as a jewelry, but
Yeah.
and since this device is always listening but transmits only when the problem is detected, What this means is that in case of that application we talked where it can detect assault, the person who is committing the assault, or who is actually the bad guy, he would have no way to actually detect this device because it's only listening, it's never transmitting. So what it
Okay.
means is
Wow.
by the time the person or the bad guy knows, it's already too late. It already detects and transmits the information. So what
Wow.
this means is that this can make such a phenomenon, such applications possible. Um, this is also another application being developed where it can detect fall. Again, the similar
Okay.
device. Okay, so if very useful for elderly people. I mean, old homes as they're called, right? Old people's home. That is being done. So this is being developed right now. There is another. I can show you another application that is being developed by a customer. This is a this is a camera, and you put a small battery. Our chip is going
Oh.
at the back here. This is our
Okay.
okay.
So, oh, just out of interest, how big is the chip itself? Because I mean, it
It's
looks very small.
yeah, it's 8 millimeter. The chip itself is very small. The packaged part is 8 millimeter on the side,
Okay. Okay.
but the chip
Still
itself,
pretty small. Yeah.
yeah, the chip itself is just this size. Hang on, are you able to see this?
Just about.
Yeah, this is
Wow. Yeah.
3 millimeter on a side.
Okay.
Okay, that's the chip. We put it in a package because the chips generally, silicon is generally brittle, so we put it in a
Yeah.
encapsulate it in a, on the, there is a cap both on the bottom and top.
Nice.
Okay, so the chip is this is a camera. You put a small battery. This is able to detect face. We can do face ID
Wow.
with this. So you can use we can use this as a doorbell. Like you have Amazon Ring device that is able to detect somebody coming at your door. That device costs 100, 150, 200 bucks.
Yeah.
This one will cost less than 20 bucks. Okay.
Wow.
What this means
That's
is, and this one, in case of all the surveillance cameras today that are intelligent, they capture the image and again send it to large computer to
yeah.
detect your face. This is able to do it all here. It doesn't need to send any data anywhere.
Wow.
This can also detect a gun, for example. That means I can protect a school. So just put a small battery here, put it around the pillars around the school, and you can protect a school using this type of device. You can protect the
Wow.
store using this type of device. And this is so portable that you will just nail it anywhere you want, right? Put it in the pillar. So you can
Yeah.
use 20, 30, 50 of these around the school. In $1,000, you can protect the entire school or entire premises. And if the battery runs out, if you lose one, no problem. It's just 20 bucks.
Yeah.
Get another one.
Wow. That's incredible.
Yes, that's how
Um,
we are, and it doesn't require anything to, it can sound an alarm all by itself.
yeah.
So this can be used for surveillance. This can be used for people if you're trying to monitor your kid. Let's say you're working in the kitchen and you have a newborn baby. You can monitor
Yeah.
if the baby wakes up. This is able to detect and able to inform you. So this type of device has become possible with our chip. Okay.
Yeah. And that's pretty high level AI as well
Yes, yes.
in terms of recognition. Just out of interest, is that I guess it can it detect individual faces? Is it at that level? Oh wow. Okay.
It's so there is a company trying to make or is working to make a doorbell application. What happens is you see in Asian countries a lot of automation. When you come in, right, they use a fingerprint recognition today. The door opens,
Okay.
lock opens when you touch the lock, right? Now you'll just come inside, you'll be able to recognize a family member and it will unlock the door.
Wow.
And if it's some outsider, then it will just send an information and you start streaming the video to the user, right? Too, so you will know who has come on the door. It's able to, it will be able to, you can use the this as a surveillance. So if somebody is passing by your house at the night, somebody is not supposed to be in your boundary, it will be able to detect that as well.
Cool.
Yes,
I've got to say, I'm pretty blown away by the capabilities of that, and especially at such low power
that's
as well,
that's,
and even more at such low cost.
that's correct.
That's crazy.
We started with economical being the theme, or ambient means for available in in and around us, on and around
Yeah.
us, right? That's the idea. There is another very interesting device somebody is building, this little bit away, but this in the future, if you're making a presentation, you can use this as a pin, and this can
Oh, okay.
recognize your voice, can recognize some commands. Next slides, previous slide, 10.
Oh, cool. Nice,
It
nice.
will be able
Yeah, that'll be
to do that,
good.
right? So you don't have to go through this. There's a company right now that actually builds for automotive the your doors on the in the car. So if you're trying to close
Okay.
the door at the in the back, the driver can operate all the windows. Sorry, not the doors in the in your.
Oh, okay.
The driver can, but if you're sitting on the passenger seat, you cannot. Right. So
Nice.
this can become voice activated. This is one of the application that has come up. Now we put this chip in the motors that are running our factories, and it will actually be able to detect if a motor is going to go bad. So that means, I mean, if you use a car, you know, the car windows motor goes bad quite often,
Yeah.
right? So, what we call predictive maintenance, you will be able to put this chip in the motors or in any mechanical device or electromechanical device, and it will be able to detect the health of that device, or it will be able to analyze the health of the device and can give you the remaining usable life as one of the application. So, in industrial, this
Excellent.
becomes extremely useful. Same thing in healthcare, as you can imagine, this becomes a very useful feature, because for especially some patients, like with the ones with Parkinson's disease who want to go around a little bit, we can make
Yeah.
geofencing using this type of technology.
Oh, okay. Nice. So obviously, Ambient Scientific is going to be joining ipXchange on our booth at Embedded World. That's 4A101.
Yes.
What, if you want to say, what kind of thing are you going to bring along with you?
We will bring some of these devices. Some of our applications are actually being done by customers. The So we're trying to procure some of those devices from customers, bring
Excellent.
to our booth, but we'll definitely bring what I showed you right now. These are still dummies,
Nice.
not functional yet, but we'll bring them just to show what is possible with our technology. So we'll be bringing those.
Cool. Nice. And in terms of anyone who's watched this and is interested in your technology, is it ready to go, or is it still in development?
This is ready to go now. We are we are already in production. So
Excellent.
yes, so we should be anybody, any company. I mean, most of OEMs, equipment builders who want to make their equipment more diagnosable, want to make it more intelligent, want to make its functionality more reliable. Those are good applications. A lot of healthcare, good applications. A
Yeah.
lot of uh, where you need voice recognition, or you need to command certain things, like in factories, people have both their hands are busy, and
Yeah.
you want to operate the machine, you would be able to do using this type of device. um, Surveillance we talked about. So these are all
Yeah.
possible applications. And as we go, even we are actually going to develop multiple chips based on this technology, which will increase the capability more and more.
Yeah.
Okay, like this one is able to do the surveillance of consumer class, but for automotive we need much faster uh, image recognition. For that, we are doing what we call GPX64, which is a 64 core device, which will be
Oh, nice.
which will be able to recognize, let's say, a few hundred frames per second. So very high speed. So even if you have very high speed drone passing by, it can still figure out what its intention.
Excellent. We will have to catch up with you when that is ready,
Absolutely.
because that would be very, very good. But thank you so much for joining us today. I think that's it. We've probably covered everything
Sound
we should cover for the moment. We got to leave something for
Yes,
for people to come and see.
absolutely.
But yes, to everyone watching, come and see this technology on the ipXchange stand at Embedded World, booth 4A101. GP, are you going to be with us, or is it just Sahash?
Uh, we most probably might have to be me or Satish
Okay.
because of the visa issues. We still have to solve these visa things. But
Yeah.
yeah,
Yeah.
well,
Cool. Well, hopefully you'll be there, because I'm sure lots of people would love to chat with you.
absolutely.
And yeah, check out the write up I did of the GPX5 and GPX10 devices on the ipXchange website, and look forward to seeing this technology in action, because it's great. Thank you so much, GP,
Thank
for
you very
joining
much,
us.
Iman, and
Cool.
look forward to seeing you guys there.
Hey, yo, where my engineers at?